Here we have IIT JEE Main math problem. Okay, let's go to the question. Find the number of solutions of the equation we have over here where x is greater than 0. Okay, in my first step, what I'm going to do is I'm going to get the factor form of this quadratic expression. Okay, let me write the given quadratic expression as it is. It is 2x squared positive 7x positive 5. Okay, now to factor this quadratic expression, I have to multiply this constant term positive 5 by the coefficient of x squared 2. When I multiply them, I'm getting positive 10. Okay, now I have to get two factors for this positive 10 so that the sum of the two factors is equal to the coefficient of x, that is positive 7. I think positive 2 and positive 5 will work. When I multiply positive 2 and positive 5, I'm getting positive 10. When I add them, I'm getting a positive 7, which is a coefficient of x. Okay, now I have to divide these two factors by the coefficient of x squared, that is 2. Okay, let me do it. When I divide this 2 by 2, I'm getting positive 1 over here. This 5 is not divisible by 2, so we can write this positive 5 over 2 as it is. Okay, now let me take x over here and x over here. This x positive 1 is one of the factors of this quadratic expression. Let me write it. And to get the second factor, what I have to do is I have to consider the stuff we have over here. Already we know that this 5 is not divisible by 2. So what we have to do is we have to move this 2 as a coefficient of x over here. When I do so, I am getting 2x positive 5. So this is the second factor of this quadratic expression. Okay, now let me continue with the equation. So let me write the first one, that is log base x positive 1. And for this quadratic expression, we got the factor form, that is x positive 1 times 2x positive 5. Let me write it positive. So here I can use the power rule of logarithm. So that is if the argument of logarithm is a power, then the exponent we have over here can be moved in front of the logarithm and it has to be multiplied by the logarithm. Then I'm getting 2 times log base 2x positive 5 of x positive 1 negative 4 equals to 0. Okay, now let me consider the argument of the first logarithm we have over here. So here we have product of two terms, x positive 1 and 2x positive 5. Okay, here I can use the product rule of logarithm. That is, whenever the argument is a product of two terms, what I can do is I can take logarithm for each term over here and I have to add the logarithms. Okay, let me do it. That is log base x positive 1 of x positive 1 positive log base x positive 1 of this term, that is 2x positive 5 positive 2 times log base 2x positive 5 of x positive 1 negative 4 equals to 0. Okay, here in this logarithm, the argument and base, both of them are equal. In a logarithm, if the base and the argument are same, then the value of such logarithm is 1. So we can plug in 1 for this one. Then I'm getting 1 positive log base x positive 1 of 2x positive 5 positive 2 times log base 2x positive 5 of x positive 1 negative 4 equals to 0. Okay, here I can combine the numbers positive 1 and negative 4. Then I'm getting log base x positive 1 of 2x positive 5 positive 2 times log base 2x positive 5 of x positive 1. When I combine this positive 1 and negative 4, I am getting a negative 3 equals to 0. In my next step, I'll move this negative 3 to the right side of the equation. When I do so, then it will become positive 3 on the right side. Okay, now let me continue on the next page. Then we have log base x positive 1 of 2x positive 5 positive 2 times log base 2x positive 5 of x positive 1 equals to positive 3. Okay, let me continue. Log base x positive 1 of 2x positive 5. Okay, here in this term, I keep this 2 as it is and I move this logarithm to denominator. Whenever I move a logarithm from numerator to denominator or denominator to numerator, I have to switch the argument and base. So that is when I move this logarithm to denominator, the argument x positive 1 will become the base and the base to x positive 5 will become the argument. Then I'm getting log base x positive 1 of 2x positive 5 equals to 3. Okay, here you may have a question. Why do I have to move this logarithm to denominator? So when I do so, whatever logarithm I'm having over here, the same logarithm I have over here in denominator. Okay, now I can assign a new variable for this logarithm to make the solving process easier. So let me assign a new variable t for this stuff, that is log base x positive 1 of 2x positive 5. Okay, now for this logarithm and this logarithm, I can plug in t. Let me do it. Then we get t positive 2 over t equals to 3. Okay, here we can assume this t as an integer. We are adding an integer and a fraction. Whenever I do addition or subtraction between an integer and a fraction, I have to multiply this integer part by the denominator of the fraction. When I multiply them, I'm getting t square. Once I'm done with this multiplication, I can take this denominator t as a common denominator. So now when I multiply this t by this t, I'm getting t square positive 2. Now we can take this t as a common denominator equals to 3. Okay, now I'm going to multiply both sides of this equation by t. When I do so, this t will cancel out. Then I'm getting t square positive 2 equals to 3t. Now let me subtract 3t from both sides. When I do so, this positive 3t, negative 3t will cancel. Then I'm getting t square negative 3t positive 2 equals to 0. So here we have a quadratic equation. Okay, now we have to solve for t in this quadratic equation. Then we'll be getting two values for t. Okay, for that we have to multiply the constant term positive 2 by the coefficient of t square. In this case it's 1. When I multiply this positive 2 by 1, I'm still getting positive 2. Now I have to get two factors for positive 2, so that the product of the two factors equals to positive 2 and the sum of the two factors equals to the coefficient of t, that is negative 3. I think negative 2 and negative 1 will work. Okay, when I multiply negative 2 and negative 1, I'm getting positive 2. When I add them, I'm getting negative 3, which is a coefficient of t. And also, I have to divide both these factors by the coefficient t square, that is 1. Even if I divide this negative 2 and negative 1 by 1, still I'm getting negative 2 and negative 1. Okay, now to get the first value of t, I have to change the sign of this first factor. It's already negative. When I change the sign, it will become positive. That is, the first value of t is 2. And to get the second value of t, I have to change the sign of the second factor. It's already negative. If I change the sign, it will become positive. Okay, now I got the values of t. Actually, t is a variable taken by us to make the solving process easier. It has to be replaced by the original stuff, that is a log base x positive 1 of 2x positive 5. Let me write it. A log base x positive 1 of 2x positive 5 equals to 2. And for this t also, we can plug in this original stuff. Then I'm getting a log base x positive 1 of 2x positive 5 equals to 1. Okay, now we have to solve for x in these two equations. Both the equations are in logarithmic form. To solve for x, what we have to do is we have to convert both these equations to exponential form. Okay, how can we convert these logarithmic equations to exponential form? Okay, let me consider the first equation over here. To consider this one to exponential form, what I have to do is I have to consider the part which contains logarithm. We have logarithm on the left side of this equation. Okay, now what I have to do is I have to consider the logarithm along with the base over here. Now it has to be moved to the right side of the equation. When I move this part to the right side of the equation, I have to ignore this logarithm. I have to consider only the base x positive 1 on the right side. The value which already exists on the right side will become the exponent of this one. On the left side, we just have 2x positive 5. So the same process I have to do for this one. So that is, I have to move this logarithm along with this base to the right side of the equation. When I do so, I have to ignore this logarithm. I have to consider only the base x positive 1 on the other side, and the value which already exists on the other side will become the exponent of this base. On the left side, we have 2x positive 5. Okay, now I got two equations. One is 2x positive 5 equals to x positive 1 the whole square. And the other one is 2x positive 5 equals to x positive 1 to the first power. First power means we can ignore this exponent 1. Okay, now let me continue on the next page. So we have the first equation, that is 2x positive 5 equals to x positive 1 the whole square. And here the second equation is 2x positive 5 equals to, let me write it, just x positive 1. Okay, now what we can do is we can solve these two equations. To solve the first one, I have to expand the square of the binomial over here. Then I'm getting 2x positive 5 equals to, when I expand the square of the binomial over here, I'm getting x square positive 2x positive 1. Okay, now what I can do is I can subtract 2x from both sides. When I do so, so this positive x, negative x will cancel. The same here. Then we get 5 equals to x square positive 1. Let me subtract 1 from both sides. When I do so, this positive and negative 1 will cancel out. Here 5 negative 1 is just 4 equals to x square. Now, to solve for x, what I have to do is I have to get rid of this square. To get rid of this square, what I have to do is I have to take square root on both sides of this equation. Whenever I take a square root on both sides of an equation, I have to consider positive or negative sign for one of the square roots. Usually we consider positive or negative sign for the square root which contains number inside. So this square root contains a number 4 inside. So we can consider positive or negative sign for this square root. Okay, here on the right side, the square root and square root cancel out. Positive or negative, the value of square root of 4 is just 2. On the right side, we get x. Okay, now I got two values for x. One is x equals to negative 2 and the other one is x equals to positive 2. Okay, now let me solve for x in this equation. For that, let me subtract x from both sides and also let me subtract 5 from both sides. So when I do so, this positive 5, negative 5 will cancel out. Positive x, negative x will cancel out. When I combine 2x and negative x, I'm just getting x. When I combine this positive 1 and negative 5, I'm getting negative 4. Okay, I have solved for x over here. Now I got 3 values for x. Here we have 2 values, negative 2, positive 2, and here one value, negative 4. Okay, according to the instruction we have in the question, x has to be greater than 0. That is, the value of x has to be positive. Among the 3 values of x we have over here, 2 values are negative, so we can reject them. We can consider only the positive value of x, that is x equals to 2. So solving the given equation, I'm getting only one solution, that is 2. Okay, now let me go to the original question. According to the information we have over here, we have to find the number of solutions of the given equation. The number of solutions of the given equation is 1.